All right, geometry. Today we are going to jump into something new a little bit. We're going to talk about trigonometry. So you had a little warm up where you had some triangles and you had to figure out what was the ratio of the opposite side compared to the adjacent side based off of that 35-degree angle. So we know ratio, you're just really creating a fraction. In this case, looking at this ratio, I have an opposite side of 3.5. I have an adjacent side of 5. If I were to divide that, I should turn out and get 0.7. Interesting enough. Let's look at this next triangle. I have a ratio of my opposite side to my adjacent side. My opposite side is 5.6. My adjacent side is 8. If I put that into my calculator, I get 0.7. Okay. Going down, I have a ratio with my opposite side of 7.7 divided by my adjacent side of 11. Put that in the calculator, I get 0.7. Ratio of opposite side to adjacent side, 63 is my opposite side compared to my 30 degrees. My adjacent side of my 30 degrees is 90. If I put that in the calculator, I get 0.7. Well, that's unique. All of them turned out to be 0.7. So using a calculator, calculate tan of 35 degrees. So if we look at our calculator, there is a button on your calculator. Actually, let me pause this really quick and pull up the Desmos calculator for you. Sorry about this. Let me pause this. All right, so if we have a Desmos calculator pulled up, we can go down here. If we go to functions, one of our functions is tan, T-A-N. So what we're going to do is we're going to hit tan, and then we want to do 35 degrees. So we're going to do 35, and I am not on the right setting. Sorry. Functions. Where is... Oh, okay. I know what I need to do. Degrees. Okay, sorry. So make sure that's on degrees and not radians. All right, so if we pull up our calculator, hit functions, hit tan. This is also on a handheld calculator. It's probably right above your digits. There should be SIN, COS, TAN. We want tan of 35. What is tan of 35? Whoa, it's 0.7. Look at that. Isn't that weird? Tan of 35 degrees gave us 0.700 something else from that. So what does tan represent? Well, if we look at all of these, we were taking the ratio of the opposite side divided by the adjacent side. So essentially, tan represents TAN. It stands for tangent, is our word we'll talk about. Tan sort of represents the ratio of a triangle with the opposite side of an angle divided by the adjacent side of that triangle compared to that angle. Let's look at another one of these. So can you figure out based off knowing that tan of 35, I know this is 0.7. Can I use this to help me figure out what is this missing side on this triangle? Well, I know tan represents, we sort of talked about, it's the opposite side of a triangle divided by the adjacent side. Well, my opposite side of my angle is x. The adjacent side of my triangle compared to that angle is 40. I know this tan of 35 has to be 0.7, so I know this has to equal 0.7. Well, I can solve this. All I need to do is, I'm going to write it down here just so I can have a little extra space. All I just need to do is multiply by 40 to get rid of it. So multiply by 40 to get rid of that in my denominator. That means I need to multiply 0.7 by 40. Well, 0.7 times 40 gives me 28. So my opposite side, my x, must be 28 in this problem. Interesting enough. Let's look at these. So let's look at a different ratio. Let's take the adjacent side divided by the hypotenuse on my triangle. So I have a 40-degree triangle right here with a right angle. I want to find the adjacent side divided by my hypotenuse. So my adjacent side is 5.22. My hypotenuse is 4. If I plug that into my calculator, I can't actually remember what that is supposed to give me. Sorry, I have my sides backwards. I apologize. My adjacent side is 4. My hypotenuse is 5.22. That is important. 4 divided by 5.22 gives me 0.766. All right. Let's do our adjacent side divided by our hypotenuse on this one. So my adjacent side is 15. My hypotenuse is 19.58. Let's divide that. Well, 15 divided by 19.58 gives me 0.766 again. So using the calculator, let's calculate now cosine of 40. So once again, if we were to pull up our Desmos calculator, we can go to functions. COS stands for cosine. So it's right here. This is cosine. I'm going to hit cosine of 40 degrees. Once again, you're going to want to make sure your calculator is in degrees. You want to make sure the degrees is highlighted. That equals 0.766. So cosine of 40 is also 0.766. So that means cosine must represent the ratio of adjacent sides of a triangle divided by the hypotenuse of a triangle. Let's look at one last pair. What if I do opposite side divided by hypotenuse? Last possible setup. Opposite side divided by hypotenuse. So in this case, I have 6 as my opposite side compared to my 25 degrees. My hypotenuse, my longest side of my triangle, is 14.2. So opposite divided by hypotenuse would be 6 divided by 14.2, which leaves me with 0.422. If I do this ratio of opposite divided by hypotenuse, that's 28 is my opposite side. It's farthest from my 25 degrees. My hypotenuse is my 66.25. If I do 28 divided by 66.25, I should also get 0.442. Well, let's calculate sine of 25. So let's go back to our calculator and see what that gives us. We're going down to our next function. Function sine 25. Sine of 25 equals 0.422. I know it looks like it's spelled sin, but we pronounce it sine. There's technically an E. This is an abbreviation. We'll look at it in just a moment. But that equals 0.422. So what does that mean sine represents? Sine must represent the ratio of an opposite side of a triangle divided by the adjacent side of a triangle, depending on that angle. Sorry, not opposite divided by adjacent. Opposite divided by hypotenuse. I'm all over the place today. Opposite divided by hypotenuse. So we have 3 ratios that work in these triangles. These are our trigonometric ratios. So our 3 trigonometric ratios. I'm going to try to find a place to put my face. I'll just leave it over here for now. All right, our 3 trigonometric ratios are sine, cosine, and tangent. So once again, sine spelled S-I-N-E. It has the abbreviation S-I-N. Cosine is C-O-S-I-N-E, which has the abbreviation C-O-S. And then tangent, which has the abbreviation T-A-N. Now, so each of these ratios represent different sides of a right triangle. They only work specifically on right triangles, which is important. They represent a ratio of a right triangle sides based off of an angle. So that angle could be any angle in your right triangle. We look at what is that angle. Based off that angle, what side is opposite of that angle? What side is adjacent to that angle? And what side is the hypotenuse? For example, sine will always be the opposite side divided by the hypotenuse. It's always going to be that ratio. Cosine will always be based off that angle of the adjacent side, which adjacent means to be next to. So the side that's next to your angle and the hypotenuse. Once again, hypotenuse is always the longest side of your triangle, always opposite of your 90 degrees, across from your 90-degree angle, your right angle. And then tangent, based off that angle, is the opposite side divided by the adjacent side. So these work because all these triangles, they're always going to be using an angle, and it's always going to be a right triangle. So we're able to create similar triangles, and we'll look at an example of that in a moment. But these three ratios, because they work for every single type of right triangle, assuming we can know one side of a triangle and an angle, we can solve for what is the missing sides of those triangles using these trigonometric ratios. And we'll look at some examples of those in a moment. But these are our three ratios, and then it's probably seeming very confusing at the moment, with sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. But I will show you some ways on how to help memorize these and how to look at these in a more specific manner. But why do these work for any right triangle with a certain angle? So let's look at this. At the very beginning, we had these 35-degree triangles. Well, thinking back to what we already talked about in geometry, we talked about similar shapes. We know similar shapes have proportional sides, meaning we can create equivalent ratios using those three sides. Well, how do I know that these two triangles are similar? Well, in order to prove a triangle are similar, we had to show angle-angle similarity. Meaning if we had two sets of congruent angles in our triangle, we could show that they were similar. Well, both of these triangles are right triangles. They both have a right angle, so that's one set of congruent angle pairs. And both of them have a 35-degree angle, so that's another set. So by angle-angle similarity, I know that these two triangles are similar. So they're the same shape, they're just different sizes. So which means their sides are proportional, meaning 3.5 over 5 has to be equivalent to x over 8. They have to have proportional sides using our similarity. We know how to solve these. We've done this plenty of times. It's just cross multiply. So I multiply 3.5 by 8, 5 times x. 5 times x is just 5x. 3.5 times 8 should give me 28. 3.5 times 8 is 28, yeah. And then I can just solve by dividing by 5. So that gives me x equals 28 divided by 5, whatever that number is. 5.6. And that is my missing side. Now, once again, I could check this by doing tangent. We said tangent was our opposite side divided by our adjacent side. Tangent of 35 should give me 0.7. So 3.5 divided by 5 should be 0.7. 5.6 divided by 8 should be 3.7, or should be 0.7. So they're all had that equivalent ratio. So this is essentially how we're able to do these. Is some mathematician out there, he looked and noticed that every right triangle with a 35-degree angle had 0.7 as the ratio of its opposite sides divided by its adjacent sides. Every right triangle with a 35-degree angle. We also noticed that every right triangle with a 40-degree angle had cosine, its adjacent side divided by a hypotenuse compared to that 40-degree angle, always turned out to be 0.776. So what these mathematicians did after noticing these with these similar triangles is they wrote all of these numbers down. They calculated this for any triangle with degrees 0 or degrees 1 to 90. They looked at all of those possible angles and calculated them for all of those shapes to figure out what are those ratios, and they wrote all those ratios down. Now, lucky for you and me, I don't have to. So it used to be where if I wanted to figure out, okay, if I have a 35-degree angle and I want to figure out what are my ratio of my sides to help me solve for a missing side, what I would have to do is I would have to open a book, find, okay, tangent 35, my ratio is this, which gives me 0.7. And I'd have to write that down, and then I'd have to go back and solve. Lucky for us, all of that information is now stored into our calculators, which is why we need our calculators in order to solve this. So you will need your calculator, whether it's the Desmos graphing calculator, whether it's a handheld calculator, we will need a calculator because we need those ratios written down in order to help us. But another thing that's super important is we have to be able to know our sides. We have to be able to label our sides as opposite, adjacent, hypotenuse in our triangles. So we're going to practice labeling opposite, adjacent, hypotenuse sides on these triangles based off that angle. So if this is my 50-degree angle right here, and this is my right triangle, I know my opposite side is always opposite, farthest away from my 50-degree angle. So it's going to be away from my 50-degree angle. My adjacent side is next to my 50-degree angle, and it's also shorter than my hypotenuse, because we know the hypotenuse always has to be the longest side of your triangle. Hypotenuse. That's a weird Y. If my 50 degree is up top, I know once again my hypotenuse is my longest side, so it's going to be this big side right here. That's my hypotenuse. Opposite of my 50 degrees is way down at the bottom, so this must be opposite. And next to my 50 degrees is my adjacent. Now I have 50 degrees down here to my left side. So I know opposite going far away is over here. Across from my 90 degrees must be my hypotenuse, which is the bottom side of my triangle. And then this top side, it's next to my 50 degrees, so it must be my adjacent side. And then lastly, we have, okay, my 50 degrees down at the bottom. I know this is my hypotenuse because it's my longest side of my triangle. Across my triangle, I have my opposite side of opposite, and then my adjacent side is right next to it. This is very important to be able to label these sides of our triangles. In order to do this, because we need to be able to figure out what ratio we need to use, because sine, cosine, tangent, they always use different sides. So depending on which sides we're given in our problem would depend on which ratio we need. So it's important for us to be able to label these sides. It will make your problems much easier. So let's actually use this. Let's actually use this to help solve us for missing sides on a right triangle. So we have 3 steps when using trigonometry. Step number 1, label the side with the opposite adjacent hypotenuse. So we need to label our triangle. Step 2, decide which ratio we need to use. So whether we need to use sine, cosine, or tangent, depending on which sides we have. And then step 3, find the length of the unknown side using our trigonometric ratios, using cross multiplying, dividing, using the trig. All right, so let's look at this first one. I have a 15 degrees. I have this x side and my 16. So first thing I need to do is I need to label my sides opposite adjacent hypotenuse. Well, I know hypotenuse is going to be the longest side. I do not have any information for that side. Opposite must be the short, far side way away from my 15. That's my opposite. And my adjacent must be the 16 side that's touching my hypotenuse. So seeing how I have information for adjacent and I need to solve for my opposite, I need to make sure I'm using a trigonometric ratio that uses opposite and adjacent. So going back to our trigonometric ratios, our trigonometric ratio that uses opposite and adjacent is going to be tangent. Tangent has a ratio of opposite and adjacent. So I need to make sure I'm using tangent for this triangle. So what I'm going to do now is I know the tangent of 15 degrees, the tangent of my angle is equal to my opposite over my adjacent side. Well, my opposite over my adjacent side is x over 16. So I know tangent of 15 degrees equals x over 16. All I need to do is solve this for x. Well, what is the tangent of 15? I have no idea. Luckily, my calculator does. So what I'm going to do is I'm going to pull up my calculator. I'm going to do tangent of 15. Once again, you can use the Desmos graphing calculator if you need to. Tangent of 15 equals 0.268. I will round to 3 decimal places. Whenever you're doing trigonometric ratios, always go to at least 3 decimal places and please round. If you don't go to 3 decimal places, you will probably round early and your answer will be off, because it's very important that we go to 3 decimal places because trigonometric ratios are very specific with their values. So we always want to go to 3 decimal places so we can be very accurate. So I know 2.68 over 1 is the same as x over 16. Once again, I'm able to put it over 1 because I know I can put any fraction over 1. So 2.68, in order to solve for x, all I need to do is just cross multiply. So x times 1 is just x. 2.68 times 16, I can easily do that in the calculator. 0.268 times 16 gives me 4.288. And that is going to be my missing side. So I can solve for my missing side using that trigonometric ratio. All I needed to know was my angle and a side length, and that was enough. So let's solve for this missing side in our second triangle. And we might stop there depending on our time. All right, so I have 16, I have 35, and I have x. Once again, first thing I want to do is I need to label my sides. So I know 16, that's my longest side, that's my hypotenuse. It's opposite of my 90 degrees. Opposite of my 35 is this side way over here. And then my x must be adjacent. It's next to my 35. It's touching the 35-degree angle. So I have information for adjacent, that's my variable, and hypotenuse. So I need to look for a trigonometric ratio that uses adjacent and hypotenuse. Well, which trigonometric ratio uses adjacent and hypotenuse? That's going to be cosine. So we're going to use the cosine of our angle. So going back to our problem, we need to figure out what is the cosine of 35 degrees, because the cosine of 35 degrees equals adjacent over hypotenuse, which is going to be x over 16. Well, let's figure out what the cosine of 35 degrees is. So we're taking our calculator, we're going to type in cosine of 35 degrees, and that's going to give us 0.819 equals x over 16. Once again, I'm rounding to 3 decimal places, 0.819. Well, 0.819 is the same as 0.819 over 1, and this I can cross multiply in order to solve for x. So x times 1 is just x, and I need to figure out what is 0.819 times 16. 0.819 times 16 gives me 13.104. So that is the length of our missing side on our triangle. And that is trigonometry. Let's see. Do we have time for 2 more? No, we're going to stop it there. All right. That is our trigonometry. We're going to practice. You're going to have a little bit more practice with this today. And we are going to have, we're going to continue to practice this and learn about this over the next couple of weeks, because trigonometry is a big, big part of geometry, and it's going to be a big part of your Algebra 2 and then pre-calculus. So you're going to see this a lot. So we want to make sure we get a good foundation on this before we move on to anything further. So let me know if you have any questions. Other than that, have a great rest of your day.